So the chain rule in differentiation, where you've got to differentiate a function of a function, and the basic formula is that you differentiate the outer function f dash of x on g of x and then multiply it by the inner function differentiated. So it's easiest to show this in a couple of examples. So if I've got y equals 3x squared plus 2x to the power of 6, to differentiate, I look at it and I say it's something to the power of 6. So if I differentiate something to the power of 6, that's 6 times something to the power of 5. And then I need to multiply it by the inside function differentiated. So I need to differentiate the inside function, differentiate 3x squared plus 2x. 3x squared, I get 6x, differentiate 2x, I get 2. Make sure you put your bracket round that. So that gives me 6 lots of 6x plus 2 multiplied by 3x squared plus 2x to the power of 5. So you then tidy it up. Another example with some trig in it. So if y equals sine squared 3x plus 2, handy hint is to write that first as sine of 3x plus 2 squared. Because if I write it like that rather than the squared in the middle, it's easy to see the inner and outer function. So to differentiate that, it's something squared. So something squared is 2 times something. So it's 2 times the something. Then multiply it by the inner function squared. So I've got sine of 3x plus 2. So to differentiate sine of something, I get cos of something. And then my final step is to multiply it by this function, the something differentiated. So differentiate 3x plus 2, and I get 3. Tidy that up. 2 times 3 is 6. And I've got cos of 3x plus 2 and sine of 3x plus 2. So sine of 3x plus 2, make sure you use your bracket, times cos of 3x plus 2. One more example to illustrate it, and I'm going to differentiate ln of sine x minus 2 to the 5. So this is ln of all of this. So the first step is to differentiate ln, and I know that if I differentiate ln, I get 1 over. So ln of something differentiates to 1 over. So 1 over sine of x minus 2 to the power of 5. Then multiply it by the something differentiated. So if I differentiate sine, I get cos. So it's cos of x minus 2 to the 5. And then the final step, differentiate this bit. So if I differentiate x minus 2 to the 5, that's 5 lots of x minus 2 to the power of 4. Something to the power of 5 is 5 times something to the power of 4. And the final step, differentiate this inner function. And if I differentiate x minus 2, that just gives me times 1. So tidy all of that up. And I've got a 5, x minus 2 to the 4. I've got a cos of x minus 2 to the 5. And that's over sine of x minus 2 to the 5. In the exam, you're likely to get more straightforward ones. So if you can do ones like this, you'll be absolutely fine in the exam. In the exam, the ones that you're most likely to get will be ones that look like this, where it's just a fairly straightforward function within a function, just 2 functions. If you think of it as differentiating the outer, multiplying it by differentiating the inner, that should help.